their data centers and manage your WAN around their data centers. And then it makes it very easy to interconnect with the cloud. So Equinix also has a product called Cloud Exchange. And on Cloud Exchange, Amazon Web Services and Azure are both there. Not everyone's there. They probably have anywhere from 5 to 20 cloud providers on their cloud exchanges today, depending on the data center location. But certainly for Amazon and Microsoft, they have very good coverage, right? So you can get your cross-connect away essentially, or one hop away from these cloud providers. And this is the product. It's called Performance Hub. And you can go to the Equinix website, you can learn all about it. You can call them up; they'll be happy to come out and tell you, hey, here's how you get my performance hubs. And then once you're there, you can see the carriers are right here. You're in the market. So this is really, I gave you the reference architecture. Here's the products that you go out and buy to deliver that reference architecture. What you then do, so you've built this high-performance core anchored on commercial data centers. You've connected it up with high-performance network. And I'm guessing that let's do another poll. How many people in the room have heard of SD-WAN, software-defined WAN? Yeah, okay, so software-defined WAN is really sort of the next generation of edge routing technology. We're really not there in core routing today, but what we're seeing, according to Gartner, I'll use Gartner statistics. So according to Gartner, about 1% of enterprises today are either looking at or have deployed software-defined WAN. 3 years from now, about 30% of enterprises will have deployed software-defined WAN. And I think that number will continue to increase. It's typically running today with the edge refresh cycle. So I've had my Cisco edge routers out there for 5 years. I'm due for a refresh. I can either refresh Cisco or I can get smart on this software-defined stuff. And I can tell you, I've been in the networking business for 25 years. This is real. I haven't really figured out SDN in the data center yet. The original sort of SDN. But for software-defined WAN, it's powerful. And quite honestly, the more locations you have, the more powerful it becomes. Because you're moving out of this world of having to manage configurations on individual routers and trying to piece together automation tools to do all of that. One of the biggest benefits of software-defined WAN is the centralized control plane. Right? It's really just a dumb x86 device at the edge. And we're able to virtualize more and more on that today. So it can be a virtualized router. That router today has some level of security. Packet filtering is built in. Load balancing across multiple WAN connections is built in. But I can take a Palo Alto virtual firewall and drop that on there. I can take an application delivery controller or a heavier weight load balancer, and I can virtualize those things and put them on the same x86 box, right? And so I get this sort of next layer of networking, and I start to sort of dematerialize all the equipment. And if you're a global business, if you're local, this isn't going to give you as big a pop, right? If you're running multiple locations across North America, bigger pop. If you're running around the world and you have to get equipment into Sao Paulo, Brazil, it's huge, right? Getting a piece of equipment into Brazil is a real pain in the neck, and getting software in, it doesn't go through customs. It goes right in, right? So it becomes very powerful from that perspective. One of the other things that's very powerful is the application layer QoS. So a typical carrier MPLS network, you've got 3 or 4 queues, and you're putting your mission critical or business critical applications in Q1 or 2, and down to best efforts in Q4. With software-defined WAN, you're actually doing packet inspection, and you're treating each application independently. So if I'm running 20 applications in a branch, I can code those 1 through 20 and give them an application quality of service. So if I run out of bandwidth at 19, those applications get kicked over to the public internet, or they don't get any bandwidth at all. But I can control that. I can control it dynamically, meaning if application 1 is most important most of the time, but tomorrow I want number 5 to be number 1, I can log into the centralized control panel. I don't have to go reconfigure a whole bunch of routers around the world. It's just centralized piece of glass, reconfigure that for tomorrow, and then unconfigure it the next day. So it's very powerful from that perspective. Also allows you to use a range of edge technologies that you can load balance across. So I can get a branch up now in a day because I can do it over wireless. I can put in a 3G card into this device, and as soon as the device arrives, I'm online. I'm not waiting for a broadband connection. I can then fortify that with a public broadband connection, an ISP connection, and if I want to fortify it further because I need 3 or 4 or 5 nines of availability, I can start dropping in Ethernet private lines. And so now I can load balance across all of those different solutions. Let's talk about mobile access for a second. I talked about how the users are distributed. They're coming off cellular networks, they're coming off Wi-Fi networks, they're coming off home broadband networks. When you move into these commercial data centers, you're going to move a lot closer to these traffic interchange points. You'll be closer to internet peering points, and so you'll be able to peer almost directly with the primary internet, right? But you'll be cross-connect away from a Comcast or from an AT&T wireless, and so you can grab traffic off those networks a lot closer to the users, keeping it off the public internet, keeping it on your express lanes. And so again, moving into these commercial data centers simply enables this. I'm going to give you an example. We've got a client, and this would be a very forward-leaning enterprise, right? They're on what I call Gen 3 of their enterprise. It's about a $500 million language translations business. They're based on the West Coast. They have started out as a call center business. They're in Monterey, next to the Defense Language Institute, and you kind of think in Gen 1 of that company, they were simply taking people out of the Defense Language Institute and put them in their call center. Right? In Gen 2, they moved to an Avaya distributed call center switch, so their agents could be remote. They could be kind of anywhere in the world, and it was all managed via TDM, traditional telephony interconnections back into that distributed call center. In Gen 3, they recently ripped out that Avaya distributed call center and went to a cloud-based contact center from a company called InContact Solutions, and InContact is in the cloud. Their physical data centers are in LA and Dallas. The intelligence for that application is in Salesforce. So here we have an environment, I was talking about where Salesforce could be a mission-critical application. For a translation call to come off, that InContact solution has to talk to Salesforce, has to come together and connect with an agent that might be anywhere around the world. And that's what we call cloud to cloud. So we talk a lot about prem-to-prem and prem-to-cloud. Here's an example where I'm trying to manage application performance and application integration cloud to cloud, and how do I do that? And so in this case, they built out, what you can see here is a high-performance core anchored on these commercial data centers, relevant to where they are and where they need to be in the cloud. This is the solid black lines are 1 gigabit core, so they've got a gigabit core here. The dashed lines are sub-gigabit, typically 100 megabit to multi-100 megabit. And then they hang their locations off the edge. So again, this is just an actual instance of that reference architecture that I talked about earlier. So that's how you do it. In summary, distributing your applications, you created this global virtual data center that allows you to distribute closer to where your users and your applications are. You're able to much more easily interconnect with cloud, anything as a service, typically software as a service and infrastructure as a service. Now that you've got this agile architecture, you're able to actually start pushing more workloads to the cloud, whether that's via SaaS or whether that's via infrastructure, move infrastructure out of the data center. And ultimately, this reduces IT delivery costs. And when you sort of embark on one of these kind of projects, you can go after it for cost savings. We've seen customers that have been able to save 50% over their WAN, but they didn't increase their performance 10x at the same time. So maybe you can increase your performance 10x for what you're paying for your WAN today, right? So somewhere on that continuum is, hey, 50% cost savings to what I'm paying today for 10%, or I'm sorry, 10x, not 10%, 10x performance improvement. And that's kind of the, I mean, this is very powerful stuff. The software-defined WAN layer is real. If you're not familiar with software-defined WAN, and you're and you're responsible for some area of networking in your business, I behoove you to go out and research it. It's here, it's real. The benefits are incredibly powerful. The technology itself is cheaper, marginally cheaper. Not you're not going to sort of save 50% over a Cisco refresh. But what you are going to save is you're going to save hours and hours and hours of manpower in terms of managing that distributed WAN. And the more locations you have, the more powerful it is. I was out at Interop a couple weeks ago, and Gap has deployed the same technology that we have. They use their Telos technology, and they've done a 1,450 site deployment. I mean, just massive improvements. They've been able to turn up 25 sites a night. Divide 1,450 by 25, they've been just chunking them away, 25 sites a night. And they don't need any specialist out there plugging these things in the retail outlets. It's a self-provisioning device. So very, very, very powerful stuff. This is where the world's going. The world is going to cloud. Traditional MPLS networks based on a hub and spoke break down. This is the kind of architecture that you need to manage your move to cloud. If you want to be successful in digital transformation, cloud transformation, this is how you build the WAN to do it. Who has the first question? Somebody's got a question. It's simple, not easy. There's a mic coming.
Your remote offices that are connected to your backbone that you built,
Right.
are they connected via your private line or are they using MPLS at that point?
You can use whatever you want, right? So, as a matter of fact, you can get some of these benefits just by putting software-defined WAN behind your MPLS and creating an express lane around your MPLS, right? So when you talk about the branch location, let's say I've got branches today connected with MPLS, right? And the typical enterprise architecture is that MPLS connection backhauling the IP traffic to some data center or centralized point where I can control the security and the ingress and egress to the public internet. And if you talk to Gartner, they'll tell you that 70% of traffic on enterprise WANs today is IP traffic. Not necessarily Spotify, it might be Salesforce, it might be legitimate IP traffic, but no less public internet IP traffic, traffic that's destined for the internet. So one of the things that we typically recommend is dropping in a broadband connection at the edge and doing a lot of enterprise